Hello, everyone. Today we are going to focus on insider threat, which refers to internal threats, which are often poorly understood. How hackers penetrate a closed network. Listen carefully. Closed means it is not connected to the internet. It has no intersection with the internet. That is, it is completely closed off. Because we include the internet in our consideration, we will discuss botnet later. Botnet, spelled B-O-T-N-E-T. It refers to a zombie network and how it is formed. It is currently connected to the internet, but the topic we are discussing today is insider threat. That is, it is a completely closed network with no connection to the internet. Let's start with this. Everyone, take a look at the entire equipment. This core switch has NetFlow capability, and there is a server farm inside. Perhaps the server farm personnel would normally place an IDS here for intrusion detection, which is a device to prevent and detect intrusion, but we are going to skip it for now. So today we're going to talk about insider threats. How hackers prepare to invade internal threats. Mainly by the company Citrix, which was hacked in the United States. Citrix was stolen by Iranian hackers 6 terabytes to 10 terabytes of data. The whole data of the submarine. So today I'm going to talk about how the hackers invaded. The FBI announced it was done through password spraying using brute force guessing. This is what you will find if you look up brute force guessing. It can use brute force guessing as a whole method. So now we're talking about insider threats. Let's take an example. It is written here in our core switch. The entire design only allows VLAN 3 to communicate with the server farm in VLAN 4. There are higher permissions here because of information security concerns. We previously set up VLANs to prevent broadcast storms. But once you do routing, everyone can communicate. However, we must set up an ACL in the core switch to only allow VLAN 3 and VLAN 4 to communicate with each other. For example, if we simulate the situation of the US Department of Defense, because this is a more critical server farm than other VLANs, such as VLAN 2 and VLAN 1, they do not have permissions to access this server farm. But hackers cannot access this server's data in this aspect. If a hacker from Iran, for example, tried to access this server, it would not be possible. You don't have to spend 10 years lying dormant for so long. He must have been here first before invading this side. See this red arrow. The hacker lay dormant here and then infiltrated the internal employees of Citrix. Because he didn't have permission to access the server farm, he had to first identify which VLAN to enter. Which VLAN would allow him to access the permissions in the server farm. He discovered that only VLAN 3 could be used. However, there was NetFlow on the core switch. Therefore, he had to pass through the core switch. See this arrow? And then he had to run to here before he could enter the server farm and steal confidential information. So, did NetFlow record the entire process of his intrusion? Okay, so why is NetFlow so important? Password spraying. It's when you use a brute force method. You use brute force to invade. If you invade here first, because I don't know if Citrix LAN 3 and VLAN 1 have this permission, I don't know. But what if we assume that he has this permission today? It's just this VLAN 1-2 server farm. He doesn't have this permission. Only VLAN 3. But VLAN 1-2 VLAN 3, he has this permission to come here. They need to communicate something with each other. So his permission is if he comes here. So let's assume that VLAN 1 and VLAN 3 have permission to communicate. He has routing function. So the hacker first used brute force attacks to infiltrate here. The result of the intrusion is that he must have left behind many small packets. I will use the live demo to show you the entire intrusion. The intrusion will leave traces if brute force attacks are used. We can use these trace packets to see the entire structure. Okay, now we're going to look at the hacker's intrusion into our system, the QLT-IDS system. They used password spraying to infiltrate from the internet and gain access to our internal systems. This is a form of brute force attack. The entire intrusion was done this way. In the case of Citrix, it was an internal-to-internal attack. In this actual case study, it would not have been possible to breach the U.S. Department of Defense or the Taiwanese Ministry of National Defense. So we're just using this as an example. This actual case study involves a hacker who successfully infiltrated from the internet into our internal systems. They did so by using password spraying as a means of infiltration. Okay, now let's move into the actual case study. Click on it. We can see the details of the actual case study. The source IP is 103. The other destination IP addresses are starting with 140. He is attacking many at the same time. Did you see this? There are multiple IPs on the screen. One IP is conducting a brute force attack on multiple IPs. Brute force cracking. He generated over 13,000 flows. So we plotted over 13,000 flows. This is a real case. Over 13,000 packets from the actual case. The packets generated. So you can see that this system can intercept all the data from NetFlow with a proportion of 1:1. All the data can be intercepted. Source IP, destination IP. It is done through RDP. It's invading through RDP. The traffic generated you can see. Looking at this traffic, you can see it's very regular. You can tell at a glance that there are more than 13,000 of them. You can tell right away that it must have been run by a program. The entire packet data is completely recorded for all 13,000. All of them are completely logged. This case is to tell you that our QLT, its device, can completely intercept hackers attacking the user unit in the entire password spraying situation. So you can see that this is a real case. Because none of this is visible on any of the IDS. But what we are going to tell you today is that our equipment can achieve this. It has already been explained in my thesis. What is called QLT IDS? It is a quantified result derived from NetFlow. It is a quantification of the intrusion. His quantification involves the use of variance techniques, statistical variance and log, as well as the concept of transforming the entire IDS. So first, let's talk about how he invaded from VLAN 1 and then invaded VLAN 3 because he had permission to do so. He could then use a brute force method to invade to here then from VLAN 3, where he had authorization to VLAN 4. Only then could he invade from here. His entire process involves password spraying, i.e. guessing passwords using brute force methods, and successfully implanting himself into the system using the same method throughout. So you see, this is called an insider threat. This is how he did it. Do you understand what I'm saying? Most people rarely realize that hackers invade from within the network. How did he manage to invade and steal confidential files? Because there are internal details involving your VLAN. There are certain situations where the VLAN can or cannot access. If the VLAN is not accessible, he doesn't have the permission to invade. He must find the authority to invade. In other words, the hacker must find out which VLAN has the authority to access the server farm. He must find it first. That's why he will lie in wait for a long time to find out which VLAN has access to the server farm. For example, VLAN 3. So he will find out which VLAN has the authority to access the server farm. For example, VLAN 1 and VLAN 3 have this routing and can access this place. If not, the hacker will continue to search until he finds a VLAN that has access to VLAN 3. If there is routing available, you can invade VLAN 4. Because it only exists in VLAN 3. Therefore, it must pass through other VLANs that are also connected to VLAN 3. In order to reach the server farm in VLAN 4 and steal data. Do you understand what I mean? This is an internal threat. Few people know how hackers can steal data from the inside. We've all heard about the FBI or someone announcing that their confidential information has been stolen, but they don't know how to do it. Using NetFlow is a good method. It can record the path that the hacker invaded. It can fully record this trace. It can record which PC is being used for the invasion. Its relay point. You have to go through core switch. NetFlow records everything above it. NetFlow will record it. So we use NetFlow. The concept of variance throughout. In my IEEE paper, I found it there. Here, it mainly emphasizes the concept of QLT-IDS. QLT uses variance. Variance, it can take NetFlow data to do a normal packet and an abnormal packet, a parallel conversion platform. You can check it in my paper. It mainly writes about this. If you can't see it clearly, I will explain it later. The math in my paper. They're all playing with math inside there. What kind of mathematical concepts are they using? So now everyone knows. Citrix was hacked and had so much data stolen. How did they cause internal threats? How did the hackers steal from this server farm? I'm actually one of those people on these VLANs. Only important people have access. Unless these people betrayed us. They didn't betray us. How are we supposed to find out? But we have a concept that says, when this company, any company, is hacked, and something happens that you haven't discovered yet, before you even realize it. If I talk about it right now, if you haven't discovered this data yet, before these things have happened, when the data has been stolen, what will you discover? You need to understand which one has or hasn't. You first need to see if there are any reports in this NetFlow. I can go and check for the reports. Like this one here. I have internal reports. They are reports on internal intrusions. I can go and have a look at these kinds of reports first. But the problem is, why Citrix? They didn't buy this equipment. Okay, in this case study, we're going to introduce internal threats. That's inside threats, and in this real case, because of this, the hacker establishes a botnet from the internet to the organization. He will invade, and then invade the internal network of the organization. He will also expand his territory by turning many IPs into his botnet, which is the zombie network, botnet. So we can see from this real case that this QLT-IDS system can detect insider intrusion. Okay, let's go into this real case. Okay, you can see this inside threat, and you can see it generates from source IP10 to destination IP, and they're all internal IPs. And there are also multiple internal IPs. An IP is invading multiple IPs at the same time. So we can see that the type of invasion includes port scan and telnet. Okay, let's click into the concept of this. He is consulting these 256 records. He went from source IP to destination IP range starting with 140. He is using port 23. That is the telnet protocol. He enters using the telnet method, generating traffic. You can see the traffic next to it. You can see that it is very neat. It is very neat and regular. Which means that this is basically being tried from that program. And you can see that almost all of the generated packets are 2 and 3. All very regular. This case is to tell you that our QLT-IDS equipment can detect the insider threats, that is, internal intrusions. It can catch them. This actual case from the internet can intercept and catch the hacker who wants to build a botnet. He goes from the internet to the internal network of the user, and then he will continue with internal intrusions, that is, inside threats, while simultaneously intruding into multiple places. This creates a more powerful botnet. That is, building the botnet. This can be seen from this case. This equipment is not available anywhere else in the world. It's only available from this company. Do you understand what I mean? In other words, you need to see the internal threats first. This is only available from this company. You must understand this. Don't tell me that. This is because the product is from Taiwan. It doesn't qualify. At least they submitted to a EEE. They also presented at the forum. A EEE recognized this concept as well. So let me tell you first. I will show you the entire process of passport spring, which is brute force cracking, and the traces it leaves behind. It involves every packet being cracked by brute force. I will demonstrate the situation to you. I will do a live demo to show you. Next, this example is great, okay? When I do an introduction, I often talk about going from VLAN 1 to VLAN 3, and then to the middle of the server farm. Analyzing the entire structure on Citrix. Going from VLAN 1 to VLAN 3, the hacker attempts to intrude. Only after going from VLAN 3 to the server farm does he have the authorization to enter the server farm. But from this case, I want to query and investigate which IP has contacted VLAN 3. Then, investigate these IPs. I must emphasize the importance of this function. Real-time querying. Our QLTIDCDS device can dynamically query NetFlow with a proportion of 1:1. That is, we can do dynamic querying. Real-time query. From this real-time query, you can see this function. I want to go and use this real-time query function. Click into it. Okay, you can see the interface of this dynamic query. Okay, now we can select the time period from here. The default is 1 hour. You can see the default is 1 hour. I will use this time to query another IP. Enter the IP. Next, I want to trace which IPs have had contact with the specific destination IP address, starting with 140. Which source IPs are involved? We have this feature on our QLT-IDS. You can query it from the default 1-hour time frame. It's usually slow on other systems, but our system is very fast. You can check from 1 hour ago to see which ones have contacted this specific IP address. Click on it. As you can see, it only took 6.5 seconds to complete the query. So you can see there are so many to the specific destination IP address. So we can focus on so many of these, like 100 of them. From source IP to destination IP, we can trace back to these source IPs, whether it's related to hackers or not. So this feature allows you to track. When I know this IP, or suspect this IP has infiltrated the server farm, I can trace it back from this IP and then continue to track and see which IPs had crossed paths with it during this time period. Which IPs had crossed paths with it during this time period? Who had contacted it here? Investigate those IPs in detail. This is called real-time query. We constantly conduct a real-time query. This way, we can understand the entire process.